Okay, it's Thursday, maybe, January 23rd. You did the Floor Surfer Lab. We finished section 1 from page 50. You need a copy of the book, even if it's the one that's online. Okay, so here's the deal. These were the instructions to the Floor Surfer Lab. You can pause this and go through there. These are in Google Classroom somewhere. Let's see here. Classwork. That needs submitted here when you're done, and I know you can do it, and I know you can find people to help. Period 1, everybody got it done. Period 6, Casey got it in here. Somebody else tried to email it to me. No, so put it in here as an assignment. Period 7, some people have it in here. So those instructions are in here in the flip chart that I'm showing you now. And there was the displacement versus time setup that I sent to you. So everybody should be able to cooperate to get this done today and put in there. And put in here. Somebody that's done it could show you. One I got to worry about is period 7, classwork. I only got a couple that need to finish it. So work together, help one another to finish that and send that in. I don't know who all doesn't have it, but here's ones that have it turned in. Hannah, Asia, Torrey, Michaela, Anthony, Liam, Dom, Connor, Caden. So well, Asia doesn't have it turned in, I don't think. Here's some more. Jeremiah and Asia, maybe to help them finish that up. You guys know how to do it. You're better at figuring that stuff out than I am. Okay, so here's the directions. Make your copy, personalize your copy so you can turn it back into me. And these were the steps to change that chart around. I have to look at those and grade them. You're changing the dot size and shape. You were changing the vertical axis and some other stuff. And then you submit it to the assignment. Don't email it to me or share it to me. Put it in the assignment. Okay, so we were doing distance over time is velocity or speed. We did page 51. Well, we did section 1. Page 51 starts section 2. I just want to talk about a couple things with you. Velocity is the speed and direction. It's meters per second usually, although we've used kilometers per hour, we use centimeters per second in the lab. Usually it's meters per second. The direction could be north, south, east, west. The direction could be degrees. In this class, we're not going to worry about the directions a lot. In physics, it's a huge deal. It could be left or right, forward, backward. So cars on a 2-lane highway, for example, can be going the same speed but have different velocities because their directions are opposite. Okay, so this is just like we're in class here. I wanted to talk about this online. In Iceland, you're familiar with the North American and South American plates are moving away from Europe and Africa, and the seafloor is spreading, and there's a mid-Atlantic ridge. You've talked about this. There's places in Iceland, which gets larger over time, and they have a lot of volcanic activity, where they have driven bars down into the ground, and then welded bars across so that there's a gap there. And I would imagine this is automated with sensors now, but they used to have people go out and measure that every week and see that it slowly, about the rate fingernails grow, works its way open farther and farther, a few centimeters a year. So this is happening. There's other place on the opposite side of the earth where the Pacific Ocean has the ring of fire, where there's a lot of subduction and volcanoes and earthquakes because that ocean's getting smaller and some land's getting sent down. Some ocean floors getting sent down under. But it brings us to momentum. And momentum is a vector also. It uses the letter P for progress, but it's mass times velocity. Mass is a scalar. For the record, velocity is a vector. You multiply those two, you get momentum. And there's a problem. Guess what? Every time we have an equation, there's a problem. On page 54, 80 kilograms times 10 meters per second east gives us a momentum. So you should be on your paper right now, and there's questions to do. You need to read section 2. So at the end of a race, I'm on page 54, a sprinter with a mass of 80 kilograms has a velocity of 10 meters per second east. What is the momentum? Well, 80 times 10 is 800. The unit is kilograms times meters per second, and it's east also. On your paper, get ready to turn this in. Turning it in at the end of class. Page 54, practice problems, number 12. Oh, well, first I want to ask you this problem. You got a car, a truck, a motorcycle, all going the same speed. Which has the greatest momentum, which has the least? Well, if they're all going the same speed, side by side down the highway, this has more mass, it's going to have the most momentum. This is going to have the least. Number 12. Momentum is mass times velocity. What is the momentum of a car with a mass of 1,300 kilograms? That goes here. Traveling north at a speed of 28 meters per second. That goes here. We are multiplying. And 1,300 kilograms times 28 meters per second north is a number that you're going to get on the calculator. Sorry, I don't have enough calculators in here yet. And you get 36,400 kilograms times meters per second. Weird unit. North, but that's the unit for momentum. Number 13. A baseball has a momentum 6 kilograms times meters per second south at a mass of 0.15. What is the velocity? Well, this time we're looking for this guy, and we have these two. So on that one, 6.0 kilograms times meters per second goes here, and it's south. And the baseball's mass is 0.15 kilograms, so we're solving for velocity. So we divide both sides by 0.15 kilograms. So that this cancels, but to be equal, it's over here. You've seen that dozens of times in here. And when this cancels, velocity equals 6 divided by 0.15. It comes out to be 40 meters per second south. Next question. Number 14. Find the mass of a person walking west at a speed of 0.8 meters per second with a momentum of 52 kilograms times meters per second west. We have momentum. We have speed. We're looking for mass this time. Number 14. Okay, so momentum is 52.0 kilograms times meters per second. Velocity is 0.8 meters per second. What's the mass? Well, we have to divide this side by 0.8, but to be equal, divide that side by 0.8. And when you do that, you're dividing by a number smaller than 1. This gets to be bigger. So it comes out to be 65 kilograms. Notice the units. All this cancels. Meters per second cancels with this meters per second, leaving just kilograms. Number 15. A basketball is 3 times greater in mass than a softball. So if they're both moving the same velocity, if this is 3 times that, momentum should be 3 times that. Okay, so we will knock it off for today with this video. Make sure you turn this paper in.